So today what we're going to do is fill in some of the gaps in the blast pressure data from FEMA's Attack Environment Manual. So what I did is I went over to NOAA, and NOAA has an Office of Response and Restoration. You can find that on the internet, and they have a lot of data on blast overpressure. And what they do is they discuss blast overpressure from hazardous materials and from different kind of disasters. And they have a lot of good information that you can utilize. They have a computerized modeling system you can actually download called Aloha, where you can do different kinds of mapping and analysis of overpressure, flammability, and what various compounds you would find in your neighborhood or your town and how they would act. So it has fuel, it has chemicals, it has all kinds of stuff in there, and you can download that on your computer. So what we want to talk about today is blast overpressure, and we want to fill in some of the gaps. And the reason I really like this chart is it gives you some day-to-day comparison things that you can think about. Now, one of the questions that comes up a lot is people say with a blast overpressure of 1 psi, that's roughly a 37, 38 mile an hour wind. And in our area, the building code requires an 80 mile an hour wind load on buildings. Down toward the coast, it's 120 or 140 mile an hour wind load. And what happens is that is the failure wind load in the building code. And when you're looking at a structure, for instance, a house, if it has an 80 mile an hour wind load, it's designed for components of that house, such as the windows, the roof, and pieces of it start to fail prior to a structural failure that makes the house uninhabitable. So when we're looking here, the figures they're giving is overpressure, which is in PSIG. And the difference between PSI and PSIG is pounds per square inch is absolute. Pounds per square inch with the G on it is gauge readings. So they're experimental gauge readings. So what's interesting is at 0.04, that's a sonic boom that can produce glass failure. So that's 143 decibels sound level. So that tells you how far below the 1 psi pressure range you start getting damage. Then typical pressure for glass failure is 0.15. So you're going to get glass failure way below the 1 psi overpressure range. And then we start getting into limited structural damage at 0.4. And then at 0.5 to 1.0 psi, windows shatter, window frames are damaged. And then in here, you can also see they're talking about minor damage to house structures. So that's internal framing, floor joists, roofing components, 0.7. And then when we get to the 1 psi we talked about before, that's partial demolition of the home where it's uninhabitable. And then you got some more information here that talks about corrugated metal panels failing, wooden panels blown in, and you can see the pressure ranges there. And then we have flying debris that actually causes injuries to people at 1.0 to 8.0 psi. Roof collapse is typical at 2 psi overpressure. And then if you look at the rest of this, it gives you information on steel frame buildings, utility poles snapping, complete destruction of homes. And then down here, I like this additional information. At 7 psi overpressure, loaded train cars are turned over. Loaded train boxcars are demolished. So that's giving you a lot of information about what happens at different psi overpressure ranges. You can use this in your planning because when you reinforce your home, you're still going to get failure of windows and certain components that you're going to have to reinforce post-attack. So please share your thoughts, comments. We'll see you on the next video.